Alright, so we're going to pick up on graph the following problem number 34. First of all, you have to remember what the original sine and cosine graph look like. So you might want to, above here, make, and I'm just going to do the first quadrant. Okay, let's do y equals sine for the first one, and y equals cosine for the next one. Right, we're going to need to remember what they look like. So your sine graph, remember, started at 0, 0. That was your sine graph. Remember we went up, started somewhere and you go up, middle, yeah, up, middle, down, up. Cosine starts here. It's the one that looks kind of like more like the U, the valley. So you take really good notes on this part. Okay, you don't have to remember how to do it. You just have to be able to transfer it on your note card. So y equals 3 sine of x. What does the number 3 actually do? What do we use when there's a 3 here? We multiply our y's by what?
3.
Right. Multiply your y's by 3. And this is sine, which is this graph here. So if you just take a graph, and you're going to multiply all the y's by 3. So let's look at our original graph. Here's our sine. My y value currently is 0. What's 0 times 0? 0 stays the same. Now move to the next one. My y value is 1. 1 times 3 is now 3. Then back to 0. Then I'm down here. Negative 1 times 3 is negative 3. And then back to 0. So it just stretched it, remember? And the directions were something like name one point not on the axis, right? Okay, do y'all remember what these markings are? You better label them if you don't know them. This is pi over what? 2. This is pi. 3 pi over 2, right? And 2 pi. So if you have to label 2 points not on the axis, you can label the top point or the bottom point. So let's say I choose this point here. Okay, you label the x-axis and then the y. So the x-axis would be pi over 2. Because we went over pi over 2. And how high did we go? 3. If you're going to label this point here, you would go out 3 pi over 2 and down negative 3. Those are your points that you would label. And it's multiple choice, so it can be one or the other. Alright, so now then we're going to look at number 36, but I'm going to make one small change. I'm going to take this 2 away from here. Okay, and I want to put the 2 in front of the x. Because remember, sometimes you can mess with the x, and those are the harder ones. There's going to be at least one of these on here, so take good notes on this part. Alright, it's a cosine graph, correct? Let's write what they do. So this negative 3 is actually going to do what to my graph? It's going to move what?
Down 3.
Right, move down 3. That part is the easy part. The hard part is when there's a number in front of x. Remember, when there's a number in front of x, you have to multiply all the x values. What are the x values on the unit circle? They're these pi over 2, pi, 3 pi over 2, and 2 pi. Okay? But when you multiply by a whole number, remember what it does. Does it shrink it or stretch it, a whole number? It's the opposite of what you thought. Right? Because I'm messing with x here. Right? So what you actually do is, remember we multiply the radians, or in other words the x value, by 1/2, remember? So if we take our cosine graph, which is up here, and the first step is let's come up with our new radians. Okay, if you move down 3, remember we're going to move down 3, and this is our new part we're going to draw. This is our new axis. So that's done. So now we have to come up with our new marks. Did we stretch it up and down any? No, we didn't. We didn't mess with. There's no number in front. I erased it. There's no number in front here. Okay, so we don't have to deal with that. But this does affect the x, right? So we multiply all the radians by 1/2. Now, normally what we have is 2 pi. So we take 2 pi, and what are we going to multiply by? Do you remember? 1/2, which comes up with pi. That's our total now. Remember how it changed the total? Okay, so our new total, and we'll have 4 marks, but because I don't have room, I'm just going to make my normal 4 marks. And there's pi. So what's halfway in the middle then, guys? Pi over what? Each part is a fourth, remember? So pi over 4, and then this would be pi over 2, this is pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. Those are your 4 marks. We got them by multiplying 1/4 by pi. Well, that's how you got your total. This is your total, remember?
Okay.
And then to get your part, because there's 4 parts, we take our total, multiply times 1/4, which is pi over 4. So each part is 1/4. So pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, and 4 pi over 4. And then you just graph it using those marks. So cosine would be up 1. I'll use a pen so you can see.
Do I have more room on the?
Yeah, you'll have more room.
I'm so happy.
Okay, this mark here then would be pi -2. You drop down to. This mark here would be pi over 2 -3. -4, sorry. Okay, so that's how you do those. They're kind of tricky. Let's move to 38. Make sure your calculator is in what? Degrees, because it's saying from 0 to 360. So check your calculator real quick. Go to mode and check for degrees. When you do that, the goal, remember guys, is to get this all by itself. That's the goal. So to get it by itself, you have to move everything over. So you're going to move the 9 over by subtracting 9. What else do you have to move over? The 2, minus 2 on both sides. So now I've got a negative secant theta equals 1 minus 9 minus 2, which is -10. You don't want a negative secant, right? So change the sign of everything. It's like dividing by -1. So now I've got secant of theta equals 10. Do y'all remember how to free theta? Does our calculator have a secant option? It doesn't, does it? So what do we have to do? Do you remember? We turn it, yeah, what do we make it? We change secant to cosine.
Oh, it's a secant, never mind.
It's secant.
I thought it was
And then what do I do to 10? I make it 1/10. I flip it. Okay, I'm going to erase this up here so that I don't have to worry.
Wait, I can get rid of the negative.
I divided both sides by -1. Now then, to come up here, how do I free theta in my calculator? How do I solve this problem? How do I get this angle? What will my calculator do? Yeah, you type in your calculator cosine -1 of 1/10. That will give you theta, or your angle. Find me the angle, please. I think it's 84. Make sure you're doing it right. You want to be able to find it. 84.26 degrees, right? That'll get you closer to the answer. But remember this, there's actually 2 answers. Okay? If you look at cosine, you think about this for a second. Alright, x, for example, can be 1. And if I'm 1, I could be up here and I could be down here. Puts me 2 spots, doesn't it, on the unit circle? So cosine is positive. That means I'm using this entire side. So it creates 2 different places I could be, okay, in my unit circle. So it could be here or here. Well, you just found this one is 84.26 degrees. That one was pretty easy. Okay, the calculator gave you that. But now we have to find the other part. We have to find this part. Do you remember how? You're close. You got the right idea. It's not 180 though. You said subtract it from 180. It's close. Well, I'm trying to go from my start all the way to here. I want to know what that is. Well, I know that if I close the gap, I've gone 360. I'm going to back up the highlighted section. How big is the highlighted section? 84. So this is 360 minus 84. Which gives me 275.74. Now let's quickly do this one.
So on the exam, for these kinds of problems, you're going to expect 2 angles.
Right.
Wait, is the exam multiple choice?
Yes.
Makes life
Now then, divide both sides by 6 on this one. To solve, you're going to take the inverse. What is sine negative? What quadrants? Here's sine. Sine is y. Sine is negative here and here. Agreed? So when you type this in the calculator, I think it gives you a negative. Can you tell me?
Yes.
Try it, because kids earlier were getting like 0.02. They were doing it wrong. Type it in your calculator. You should actually get negative 9.59, right? Right, but the direction said it had to be positive. So you have to find 2 more. Right, ready? So let's think about this for a second. I'm going to start here, and I'm trying to travel all the way to this line. So I'm going to go 90, 180, and this much more. How do I find out where this line stops? Right, add 9 to what? Good. So this first mark is 180 plus 9.59. 189.59. To find the second mark, what are we going to do? Yeah, you're going to go from here all the way to there. Which remember, that's the backing up. 360 minus 9.59. Which is 350.41. Those are your 2 answers. Now let's do this one. The difference is, what's it in instead? Radians. So get your calculator, change to radians. You want to be in radians. And instead of using 180 and 360, we use 3.14 and 6.28. You might write that down to help you. So let's solve it. Which calculator? So subtract 6 from both sides. So now negative 2 cosecant x equals negative 13. Divide by 2. Actually, divide by negative 2, I'm sorry. Which gives you 13 halves. Can we find cosecant on our calculator? No, so we change it to, what's the flip of cosecant? Sine. So then we look at our little picture. When is sine? When is y positive? It's positive in this quadrant and this quadrant. When you type this in your calculator, you get 0.15, right? So we have part of our answer, so this is 0.15. How do you find the other answer? Think about it. All the way would be 3.14. And I've got to back up just a little bit. So how do I find the other one?
90 minus the.
3.14 minus 0.15,
Oh, wait, yeah.
which is 2.99. So 0.15 and 2.99. Remember, because we're using 3.14 and 6.28 instead of 180 and 360.
I realize that.
Yeah, it's okay. That's why I'm practicing it. Be sure then to put that one on your note card. Alright, how many of y'all remember these fun ones? Sine. Okay, I'm gonna do number 42 with you. You ready? Just to kind of get your, if you don't know your identities, you better write them on your paper, right? That's what you have the note card for. What can we do here? Did you see a shortcut? Well, I see one. It's called easy. What is this right here? A secant and a 1 go together. What do they make?
1.
No.
They do,
Secant squared x minus 1. Get your identity. It's what? Joe Chase.
tangent squared, it's tangent squared.
Right. Remember the ST go together? ST? So sine squared of x over tangent squared of x. Which can be rewritten? Tangent. So now we've got sine squared of x over 1 over tangent, which is sine over cosine. They're both squared. Now what do we do? Fraction over fraction, that's complex. What do we do? Yep, you flip the bottom. So now you have cosine squared of x over sine squared of x. We're multiplying, so we don't need a common denominator. What happens? They what? They cancel, and the answer is cosine squared of x. Okay, in your spare time, if you'd like to try, you might try number 43. The answer is 1. On 44, the answer is 1. We've done 45 and 46 pretty recently. Why don't we go back really quick up to 41? No, I'm sorry. These are fine. 1 and 1. Try those, and then you can start working on your note card.
43, 44.
Okay, just do 41 and 44. See if you can get. No, I keep saying the wrong problem. 43 and 44.
Okay.
Sorry, my fault. Alright, you can work on your finishing those and then make your note card.